To fully understand the application of outdoor reset and the benefit to the homeowner, it's important to realize that the goal of any heating system is to maintain a constant room temperature during the heating season. Now, of course, the heating system's designed to heat a given room under design conditions, that quote-unquote coldest day of the year. In a radiant heating system, the radiant design calculations will tell you, based on the heat load of the room, the floor covering, and the installation method of the tubing and the tube spacing, what water temperature you're going to need to heat the room under design conditions. Both the three-way tempering valve and the set point eye valve will provide that water temperature for you, but that water temperature will be fixed all winter long. In this case, 115 degrees all winter long. But what happens when the outdoor temperatures change? Well, it should be obvious that the heat loss of the structure is based on the outdoor temperature. The colder the outdoor temperature, the greater the difference between the indoor room temperature and the outdoor temperature. The greater that delta T, then obviously the greater the heat loss of the room will be. So as the outdoor temperature goes down, the room's heat loss will go up. Conversely, when the outdoor temperature increases, the room heat loss will decrease. So how do these changing weather conditions affect radiant system water temperature? Well, obviously, if the heat loss of a room goes down as it gets warmer outside, the room doesn't need as much heat. And obviously, we're not going to be adding or removing radiant tubing from a room during the course of the heating season. So really, we're left with just two choices for maintaining comfort and preventing overheating. We could provide either a fixed temperature system with a tempering valve or the set point eye valve, or we could provide a variable water temperature system using the reset eye valve. With either option, it's obvious that the heat loss is going to vary every day based on how cold it is outside. With a fixed water temperature system, the water's always going to be the same temperature. The only way to prevent overheating, therefore, would be to vary the run times of the system. Shorter run times in milder conditions, longer run times when it's colder out. This, unfortunately, will lead to short cycling of the boiler, and that leads to lower overall system efficiencies. And more on-off cycles will also lead to more wear and tear on all of the moving parts in the system. With outdoor reset, however, the supply water temperature will vary in lockstep with the outdoor temperature. The colder the outdoor temperature, the warmer the water is going to be. If both the heat loss and the water temperature vary together, then the run times for the system, in theory, would have to be fixed all winter long. The system will always think it's the coldest day of the year outside, so the system on time should be constant. This will lead to greater system efficiency since the boiler won't short cycle as much, and will also lead to less wear and tear on the system components, and that leads to longer life and lower maintenance costs. So that's what an outdoor reset control does, but how does it know what to do? How does it know what water temperature to produce? Well, that's all based on four numbers used in programming. The first number that you need is the outdoor design temperature, or the temperature upon which you've based your heat loss. This is the so-called coldest day of the year. The next number you need is the mix design temperature. This is the water temperature that the radiant system requires when you're under design conditions, when you're at the coldest day of the year. This number will be determined during your radiant design calculations. Next is something called WWSD, or warm weather shutdown. This occurs when the outdoor temperature is equal to the desired indoor temperature. When that happens, the heat loss of the building is zero and no heat is needed. In the warm weather shutdown mode, the eye valve will not enable, thereby preventing heat from being supplied to the building accidentally. The final number you need is the mix start. That's the water temperature you want running through the radiant system at the warm weather shutdown point. The eye valve defaults to 72 degrees. Using these four numbers, we can determine the reset ratio needed to program the reset eye valve, and we use this formula. We take the mix design temperature minus 72 and divide it by 72 minus the outdoor design temperature. That will give us the appropriate reset ratio. So let's do one. Let's try an example that we have here. Let's say we have an aluminum panel radiant system that requires 130 degree water at an outdoor design temperature of 0 degrees. If we do the math, we'll find the following. First, we divide 130 minus 72 by 72 minus 0. That winds up being 58 divided by 72, and if we divide that out, we will find that we have a reset ratio of 0.8. Now we can verify that by looking at the chart on the right-hand side of the screen. First, we find 130 degrees over on the supply water temperature side, and then we find the outdoor design temperature on the bottom axis. of 0 degrees. We follow the two lines to where they intersect, and it should be at the diagonal line that represents an outdoor reset ratio of 0.8. So we know what the reset ratio is, 0.8, but what does it actually mean? Well, by setting the reset ratio to 0.8, the control will know to follow the line in the chart represented by 0.8. When the outdoor temperature changes, the radiant supply water temperature will change as well, moving right across that line. In essence, what 0.8 means is that the radiant water temperature will increase 0.8 of a degree for every 1 degree drop in outdoor temperature. And programming the iValve is very, very simple. Once we know the ratio, all you have to do is adjust the dial on the control so that the head of the arrow points to the desired reset ratio.